Hello students, this is Praveen Shukla and today we are going to discuss about very important chapter of chemistry class 12 solutions. See, first of all, I just want to let you know why solutions are important. Why should you learn about the solutions? What is its exactly meaning and later on what we are going to learn about the solutions. So here we will go through what is mentioned in NCERT because the examples were provided here in NCERT book during the initial stage of this chapter. They are little bit heavy for this stage, so that's why I want to use the same example. Okay, let's go. Solutions, as the name suggests, it is a mixture of two or more than two substance. Why you want solutions? First of all, see, uh, any substance in pure form, it is useful, like hydrogen. If hydrogen is alone, it is useful. If hydrogen making bond with oxygen, creating water, and water is also useful. If I discuss about in solid states, like let us say copper in pure state, it is of course very useful. Copper wires we are making, and through copper wires electricity is passed and supplying the electricity to villages, cities. Okay, but if you mix copper with zinc, then it becomes brass. If you mix copper with zinc and nickel, then it becomes um, sometimes it is said German silver. And if you mix copper with tin, then it becomes bronze. So copper alone useful, copper mixing with the zinc also useful, mixing with the tin also useful, and mixing with nickel also useful. And zinc, nickel, tin, they are also as a pure substance useful. So to make life more easy, to make products that can be used in different in scenario, different applications, so that we can generate such a product which solve our problems of life or which makes the life more comfortable. So two or more than two substances are mixed together in a particular ratio, in a specific proportion, so that another useful product can be generated which helps the society. Like salt alone useful, ठीक है, खाना बनाते हैं उसमें सॉल्ट डालते हैं, थोड़ा टेस्ट आता है. Sometimes salt you are mixing with the water, you are making salt water solution. Salt water solutions also used in different applications. Sugar alone useful, water alone useful, but sugar mixed in water, it is having a different application. Like you are making a tea, so in tea what you are doing, water, milk, tea, sugar, everything together, making a solution, boiling it. Okay, so if I say you, if you want to have a tea, okay, let us drink some water first, then some milk, then eat tea, then eat little bit sugar, you will be satisfied. Is this okay? Are you comfortable for this? No. So better let us make a solution of all these items, boil it at a particular temperature, and let us make such kind of product which is really you want at this stage of this point of time, which can relax your stress. So you will make a tea. Same way in chemical reactions or in chemistry, different products, different substance come together, make a chemical reaction, generate a third product. So now this why I am explaining you all these things. I just want to make you more comfortable about what exactly the solution and why you are studying it. Sometimes solutions they are not always useful. If one product reacting with another product and creating something disastrous or something energetic, evolving, discharging more energy which can damage something. So it is also, you have, when you are making a solution, you have to be very careful. You should have first understanding what exactly you are going to do, in what proportion you should mix the two substances. Like here another example is given: 1 part per million 1 ppm of fluoride ions in water prevents tooth decay. 1.5 ppm only parts per million in water prevents the tooth decay, while 1.5 ppm cause the tooth to become mottled, and high concentration of fluoride ions can be poisonous. So while making solution, you have to be very careful. You should take the guidance of experts. Don't try by yourself without understanding the procedure, standard operating procedure, or should should do such kind of practicals under the guidance of lab chemist. Another important example they have given here. What is this? Yes, ions can be poisonous. Okay. Intravenous injections are always dissolved in water containing salt at a particular ionic concentrations. Intravenous injections, which they are giving us while certain kind of treatment. Okay, they are always dissolved in water containing salts at particular ionic concentrations that match with blood plasma concentrations and so on. So see, you cannot give any injections. Okay, it may be pure substance, so which is dissolved in the water which contains the salt. So here you are making some sort of solution, then only you are giving then only this medical practitioners are giving in your venous. And this solution what they are making along with the injection, water and salt together, it should match with your blood plasma concentrations, means blood quality. So study of solution very important. And what the examples they have given here, I explained you very well. So we will move on now. Okay, in last slide we discussed little bit about the injections which are being given by medical practitioners in venous. So here the important and heavy example what they have given, blood plasma. Little bit I just want to uh, explain you what exactly the blood plasma is, although it is not very necessary at this stage, but anyway here they use this word, so it is I will explain you a little bit what exactly the blood plasma is. Blood plasma is actually it is the liquid component of blood that makes up about 55% of total blood volume. Uh, it is a yellowish colored liquid that contains water, protein, nutrients, and I think hormones, waste products, and other substance which is necessary for the body to function properly. Yeah, one more thing. Plasma also carries red and white blood cells and platelets throughout the body. So plasma is important for several medical procedures, which includes blood transfusions, which are often necessary for the people who have lost a lot of blood due to surgery, trauma, or illness. So anyway, we will not go more in detail, but here as they use blood plasma, what, that's why I explained you. So intravenous injection, that are why they are dissolving in the water, because they whatever the injection, whatever the treatment they are giving, uh, it is it should be suitable and compatible with the blood plasma of the patient. So whatever the solution you are making, you should be completely aware about what exactly you are going to do after making this solution, for what you are making, because it is not always uh, useful product you are going to make with the solution, means what I mean to say, mixing with pure substances. You should have a good knowledge, and you should know exactly what you are going to do with this. Yeah, if you are doing experiment like on a scientist level, then okay. But even though as a scientist, if you want to do experiments, you should have a very good background about basics of the items which you are going to mix. I think I should give some examples of hazardous solutions which unnecessarily made, and later on they created some problem. Wait, let me remember. uh, okay, like acids and bases. So if you are mixing strong acid and base, it can cause a violent reaction. It releases the heat and gas, and it can cause an explosion as well. For an example, mixing hydrochloric acid and sodium hydroxide, it can create salt and water, but it also release heat and gas, which can cause an explosion. you know so must be very careful. Don't do any experiments in chemistry lab without any guidance. Another example, like LPG, yeah, which you are using at home. So LPG is basically gas. So if there is any leak, and if it is mixed with air and minor ignition, if it gets from anywhere, it can start burning. It can, the mixture of LPG gas, propane, butane, along in air, it can create explosive mixture. So you have to be very careful. But that is why chemists are there. They know very well which substance to be mixed with which and in what proportion. So here the expertise come into picture. That is why this chapter is there, and we want to make you understood about how the solutions are important. See, technology, knowledge, or something what you observe, or what you get from discussions. So knowledge, so consider all these things as a tool. It's not only about learning something and writing the exam. You should understand each and everything as a tool which is very useful to the society and useful to you as well. At this point of time, your focus will be mostly on on your marks. Okay, this is solution chapter. Maybe 10 marks of question will come in exam. That's why you are studying. No, you just study it as a what why this chapter is there, what exactly you are going to learn about solutions in future, how it will be useful. If you want to have a discussion with some expert, then what kind of questions you should ask. You should be uh, make yourself as a in future, not at current position I'm talking about. In future you have to make yourself professional guy which speaks technical things. Okay, so anyway, don't get ourselves diverted in another direction. Let's focus on topic. Okay, in this topic we are going to discuss about different types of solutions. As I explained you earlier, solutions means mixture of two or more than two substances together, which are producing or going to produce another product which is useful for the society. So two or more than two pure substances together mixing, but but the question should come in your mind: two or more than two substance, but in which state? Substance can be either solid, liquid, gas. So see the types of solution based on that only: gaseous solution, liquid solution, and solid solution. Okay, if I talk about liquid solutions only, so uh, let us take an example. If you are mixing salt in water, salt is solid, water is liquid. So what kind of solution it is? It is liquid solution or solid solution? Here you used salt which was solid, and you are mixing solid in liquid. Ultimately what you are getting, whether this will be a liquid solution or solid solution, this will be a liquid solution. Why? Because the state of the you know uh, state of state of a solution depends upon the state of substance which is present in larger quantity. Like there is a water, there is a salt. Who is present in large amount? Water. So solution state will be liquid, because water in liquid state. Same in case of solid solutions. Solid solutions like mixture of copper and gold. Okay, if copper is dissolved in gold, okay, this is the solid mixture, so the solution will be solid. If I take an example of amalgam amalgam of mercury with sodium. Okay, amalgam of mercury with sodium. So this kind of solution will be solid solution, because one is liquid, another is solid, but the larger amount present is solid state. Another example, if I give you solution of hydrogen in palladium. Okay, this is little bit heavy, but the examples they have given here, you have to just imagine. I don't want you to imagine only. Let me explain you what is palladium and how solution of hydrogen in palladium, how they are making. Because okay, first of all, uh, what are the types of solution? I explained you. Based on the state of solution, it can be gaseous solution, liquid solution, and solid solution. And in each solution there are two things. One is solvent, another is solute. So what you are going to mix is called solute, and in which you are going to mix, like salt is solute, and salt you are going to mix in water, so water is solvent. So whichever the substance present in large amount or larger quantity, that is called solvent, and a smaller quantity, that is called solute. And whichever the substance present in larger quantity, that only decides the state of solution. Okay, So I was discussing about the example solution of hydrogen in palladium. Let us discuss a little bit more. The solution of hydrogen in palladium, yeah, of course, it is a type of solid solution. Hydrogen, it is a gas. Palladium, it is a metal, means solid. So how gas can be dissolved into solid? Is it possible? Yes, it is possible, but not for all kind of gas and or for all kind of metals. Some kind of solution can be made, but not you cannot mix everything with everything. Okay, so here in this case, first of all, I will explain you how it is formed, how this solution is possible. See what happens in this case. Uh, Hydrogen atom, when it happens, when you can make this kind of solution, when hydrogen atoms are absorbed into the lattice structure of palladium metal. So when hydrogen is absorbed into palladium, it forms a type of interstitial solid solution where the hydrogen atoms occupy the space between palladium atoms in the crystal lattice. See what happens, there is a little bit space between the palladium atoms in its crystal lattice. So there hydrogen atoms move and fix their position. So actually this is the process of absorbing hydrogen into the palladium. This process is called hydrogenation or palladium hydride formation. Now hydrogen is getting absorbed in palladium, so hydrogenation or palladium hydride formation happened. Actually what happens when hydrogen getting absorbed, so hydrogen will cause the palladium crystal lattice to expand, and the resulting solid solution is it will be typically softer and more ductile than pure palladium metal. So okay, up to this extent okay, because what the example they have given is very little bit heavy, but that's why I explained you more in detail how gas and solid can be mixed together. Because in the solid crystal lattice structure is like that, some gaseous atoms can move there, fix their position and permanently sit there. That is why you can find this kind of solution. Okay, now hydrogen atoms went in the palladium crystal lattice, sit there, move there, fix their position, but what is the use? Ultimately it should be useful. So the solution of hydrogen in palladium, it has a very important applications. It includes the hydrogen storage and purification. Palladium hydride, it can absorb large quantity of hydrogen gas, making it useful as a hydrogen storage material for fuel cells and other applications. And palladium hydride can be used to purify hydrogen gas by selectively absorbing impurities such as carbon monoxide. So the solution of hydrogen in palladium is also, actually it is also important in catalysis, where it can be used as catalyst for various chemical reactions such as hydrogenation and dehydrogenation. So such kind of solid solutions where the gas is absorbed in the solid, that is also very important for different applications. Now another example of solid solution, when liquid get mixed into solid. Solid solution means solid amount of solid is higher, it is called solvent, and amount of solute, it can be gas, liquid or solid. So amount of solute is less, and type of solute if it is liquid. So liquid and solid both together making a solution. Here the example they have given, amalgam of mercury with sodium. So we'll try to understand what is this. So in this case, the amalgam of mercury with sodium, it is a type of alloy that is formed by combining liquid mercury with solid sodium metal. So here solid is sodium metal, liquid is mercury. So when both are mixing, it, it, the resulting amalgam, it will be soft silver gray material that is I think typically used in reducing agent in organic chemistry and as a source of sodium in various industrial processes. So its industrial applications are there. But here one important thing about amalgam of mercury with sodium is the process of forming this amalgam. It is exothermic, means it releases heat and it can be dangerous if it is not done properly. So the reaction between liquid mercury and the solid sodium, it can be violent. It can release hydrogen gas which can be explosive. That's why I told what you are listening or what you are reading, don't read or listen just like a, as chapter or in marks point of view. Just imagine as a chemist. If you are a chemist working in some lab and I and your boss tell you to make a amalgam of mercury with sodium, so you have to be very careful because the reaction is exothermic, it releases the heat, it can be dangerous if not done properly. And who will affect? Very first you will be affected because you are the nearest person who is performing this experiment. So first of all, safety of yourself, then safety of lab, then safety of wherever the institution you are working, safety of society. Chemist job is very important. Don't consider it as a just 5 words which is written as an example. Why I am explaining you example in detail? Because I want you to make more sensible about chemistry. Now, and also one more thing, because and also because the example what they are using, it is heavy one. Unless until I will explain you more in detail, you cannot understand it properly. Another example, solid that copper dissolved in the gold, that already I explained. Oxygen dissolved in water, how it is possible? First of all, we'll see. Oxygen is a gas, water is a liquid. Now you are going to dissolve gas into liquid. So in this example, it can be dissolved through a process which we call it as gas exchange or aeration. So this occurs when it happens. It occurs when oxygen gas in the air comes into contact with the water surface where it can dissolve into water. So the amount of oxygen that can dissolve in water, it depends on several factors. It's not like water is there and air is there and now air oxygen will start getting out from the air and it will dissolve in water. It's not so easy. It depends on several factors. It includes temperature, pressure, presence of other dissolved substances, and how much the oxygen, you know oxygen will be dissolved in water, what we call it solubility of oxygen in water. So it goes down as the temperature of water increases. It means warmer water, it can hold less dissolved oxygen. Similarly, the solubility of oxygen decreases as the pressure of air above water decreases. Means water at higher altitudes, it can hold less dissolved oxygen than water at sea level. So once the oxygen is dissolved in water, it can be used by aquatic organism for respiration. Also, it is good if you maintain an oxygen level in water, because it prevents the buildup of harmful substances such as ammonia and hydrogen sulfide. Okay. Maybe you have heard somewhere the oxygenated water. Oxygenated water, it is a type of bottled or canned water that has oxygen which is added into it. The purpose of adding oxygen to water is to provide various health benefits. It includes better exercise, recovery. I don't think there is a evidence, but people say so. Here I explained you very well about how a gas getting dissolved in water. Okay, now we'll discuss about gaseous solution. Gaseous solution means solvent will be gas, solute can be gas, liquid or solid. So gas mixing, very easy, not much pressure, not much I mean to say not much effort, like air. Air is a mixture of not only one gas, it is a mixture of oxygen, nitrogen, and impurities are a lot, polluted environment. Okay, example of gas mixture where solid is a liquid. So here the chloroform is a volatile liquid that can easily evaporate and form a gas. So now you can have little idea how it is getting mixed with nitrogen, because nitrogen is a gas, chloroform is actually a liquid but volatile liquid. Volatile liquid means it can easily evaporate and it can become a gas. So as soon as it comes in contact with nitrogen, it by itself, its property, it is a volatile, so first of all it will convert into gas, and now both have become gas. So gas and gas mixing, very easy. But for particularly for this example, what I am saying, when it is mixed with nitrogen gas, it can form a homogeneous mixture in which chloroform molecules, actually they are dispersed throughout the nitrogen gas. So the properties of this mixture, such as its density, boiling point, it all depends upon the relative amounts of chloroform and nitrogen in the mixture. So this kind of mixture, it will not be, its property will not be the same. If actually it depends upon the portion in which they are mixing. Okay, one more important thing about this particular example I want to share with you. Chloroform, it is actually a hazardous substance. It can be toxic if it is inhaled or absorbed through the skin. Actually, it was used as an anesthetic in the past, but its use has now largely been replaced by some other safe alternatives. So mixing chloroform with nitrogen or other inert gases may be done in some laboratory settings for certain applications, but it must be done with appropriate precautions and safety measures in place to prevent exposure to toxic chloroform vapors. Okay, let's move ahead. What's the next? Solid. Solid is solid, solvent is gas. Very easy example, camphor in nitrogen. See, camphor actually does not dissolve in nitrogen gas because nitrogen is inert. Inert means it is not able to ability to react, does not have ability to react. So how camphor will dissolve or react with nitrogen? Actually it is not a chemical reaction, but camphor can be mixed with nitrogen. It forms a homogeneous mixture. Okay, so here in this case, how you are going to make a mixer? So camphor can be mixed with nitrogen gas. You have to place the camphor in a container and then flush the container with nitrogen gas. By this method you can make a camphor and nitrogen mixer. So this process, it helps to protect the camphor from the exposure to air or other reactive gases. So the amount of nitrogen gas you are going to use, it depends upon the desired concentration of camphor you want in the mixer. But where it is used, camphor with nitrogen gas mixer, where it is used? It has various applications. It depends depending upon the specific property of mixer. Like it is used in calibration of equipments, calibration of instruments. So camphor is mixed with the nitrogen gas. It can be used as a standard material for calibration of instruments such as melting point apparatus. The mixer can be used to establish the melting point of camphor, which is well defined standard temperature for comparison with other substances. Again, this mixer we can use to establish the melting point of the camphor, which is well defined standard temperature for comparison with other substance. Okay, so to make the comparison with other substance, this mixer is used. What else? I think medicinal products it is used. It is used in I believe it is used for anti-inflammatory and analgesic products. See, mixing camphor with nitrogen gas, it may help to protect the camphor from degradation or other chemical reactions that could affect its effectiveness. So sometimes you want to protect camphor, that's why you are mixing it with the nitrogen. Okay, so why I'm explaining too much the examples? Because the example is given here, just if you go and read, you will not be able to imagine what exactly this is. So that is why I'm going on the next stage to go more deep in example, and better you use this kind of examples only which is already given in your NCERT books.